This is going to be part 2 of the previous lesson, when we're graphing rational functions again, but we're going to have different examples for this one, so just be ready for it. Okay, so we're going to go ahead and we're going to start with example number 1, where we're going to have no asymptotes. So you have g of x equals to that function right there. If you guys remember from yesterday's steps, the first thing is to factor the numerator and the denominator. But if you look at this here, this x plus 2 is already in factored form, so there's not really anything I can do. But this numerator here, I can go ahead and factor it by using difference of squares, right? So we're going to use difference of squares, meaning that I'm going to square root the 4, which gives me 2. And then because it's a subtraction, that means that I'm going to have a plus and a minus. So now that I have that right there. Okay, so now if you notice, I can go ahead and cancel out any common factors, which would be these x plus 2's, leaving me with just an x minus 2. Okay, so now here, okay, we go ahead and see, okay, well, do I have a vertical asymptote? And the answer to that is no, because whatever I did have in the denominator right here, it got canceled out with this up here. So now I just have x minus 2. Now, do I have a horizontal asymptote? Okay. Well, remember that for the horizontal asymptote, we have to get the highest degree with the lowest degree. So my degree here is 2, and the degree here in the bottom is a 1. So that's 2 over 1, which is 2 is greater than 1. So that means that there is no horizontal asymptote because the m is greater than the n. So there is no horizontal asymptote. Okay, now we go ahead and we find the zeros, which are also called the x-intercepts. Okay, and you just get your numerator and you set it equal to 0, which is x minus 2 equal to 0, because that's all that I have left over here. Okay, guys, if you look at this here, this is all that's left. So that's why I get it here and I set it equal to 0. I add the 2. So now x is going to equal to 2. So what are my zeros? My zeros are going to be 2, 0. Remember, it has to be in ordered pair form. Okay, I do not want it in x equals to 2 because this right here is a line. This right here is a point. Okay, so 2, 0. Okay, now we go ahead and we look for the y-intercept. Okay, and for the y-intercept, you make x equal to 0. So I'm going to go ahead and get y equals to 0 squared minus 4 over 0 plus 2. Well, 0 squared is 0. Minus 4, 0 plus 2 is 2, 0 minus 4 is negative 4 divided by 2. Negative 4 divided by a negative divided by a positive is going to be a negative. Now 4 divided by 2 is going to be 2. So my y-intercept is going to be 0, negative 2. Okay, now let's go ahead and see, do I have any discontinuities? Yes, I do. Now I know that I canceled it out, right? But it's still going to be a discontinuous one, right? Now what kind? Removable or non-removable? Well, because we took it away, it's going to be a removable discontinuity, right? So my removable discontinuity is going to be at x plus 2 equals to 0. So you subtract the 2, and now x is going to equal to negative 2, right? Now, this removable discontinuity, guys, we are going to call a hole. Okay? This one right here is going to be called a hole. Okay? So I'm going to have a removable discontinuity, which we're going to call a hole, at x equals to negative 2. Okay? So we're going to have a hole at x equals to negative 2. Okay? let's go ahead and find the domain and range. Well, this whole is actually going to be an ordered pair. So we actually need to find the y value. But what you can go ahead and do is just get the x and plug it in here. So to find the y value for the whole, we can go ahead and use what we got left, which was x minus 2. So we're just going to substitute it with a negative 2. So now I'm going to have negative 2 minus 2, which is going to be a negative 4. So my whole is actually going to be at negative 2, comma, negative 4. Okay? And now for the domain is going to be all x values such that x cannot equal to negative 2. Because that was our only discontinuity, right? That was our only whole, which is right here. That was the only discontinuity. That was our only denominator right here. So my domain is going to be that. Now my range is going to be y value such that y cannot equal to negative 4. Okay, and why is that a negative 4? Well, because we have a whole, right? Remember, this is our whole. Where's the whole going to be? At negative 2, comma, negative 4. So if you notice, the domain here is going to correlate with the negative 2, which we have right there. Now for the range is going to correlate with the y value, the negative 4, which is right there. So whenever you have a whole, it's going to be a discontinuity. So make sure to include that in your domain and range. Okay, so now our next step is going to be to graph all of this. Before I forget, let's go ahead and do the sign chart. Kind of forgetting about that one. So for the sign chart, remember, we need to use the zeros. Okay, so we do a sign chart, and we have to look at our 0, which is 2, comma 0. So that means that the number that I'll be placing here is going to be a 2. And now I need to pick values that are less than 2 and greater than 2. Okay, so I'm going to go ahead and I'm going to pick 0 here. And then for 2, I'll pick 3 because 3 is greater than 2. And we're just going to go ahead and we are going to plug it in to the equation. So I'm going to go ahead and I'm actually going to use the simplified equation right here, the x minus 2. So I'm going to go ahead and use 0 minus 2. What's 0 minus 2? That's a negative 2. So I'm going to end up with a negative there. Now I'm going to go ahead and do 3 minus 2. So I'm using x minus 2 here. 3 minus 2 is a positive 1. So then I have a positive here. Okay, so now let's go ahead and use all of this. So my zeros is going to be at 2, comma 0. 1, 2, comma 0. My y-intercept is at 0, comma negative 2. 1, 2, negative 2. Okay, and then I'm going to have a whole at negative 2, comma negative 4. 1, 2, negative 2, comma negative 4. So that right there is my whole. Okay, so I already did that, did this, and I did this. No vertical asymptotes, no horizontal asymptotes. So that means that I have this 2 right here, which is this. And it says that anything on the left side is going to be going towards the negative side. So that means that I'm going to go ahead and I'm going to bring this line down like this. And it's just going to continue. And then anything to the right of 2 is going to be positive. So the right of 2 is right here. And going right means that I'm going to have to be going upwards. And so this is what the function is going to look like. Now, is it going to curve? No, because I have no asymptotes to curve it up or downwards. So it's literally just going to be a straight line. And I know that it's going to be a straight line because x minus 2 is linear. How do I know that it's linear? Because x has a power of 1, right? And that looks very similar to y equals mx plus b. Now we're going to go ahead and move on to example number 2. Okay, now for this one, we're going to be looking at something that has us crossing horizontal asymptotes. Okay? And these are the situations and the examples where that can actually happen, right? Or horizontal asymptote. Okay? So our function is going to be x over x squared minus x minus 2. So we start off with the first step, which is factoring. So I got x, and then here I'm going to have x times x. Now what times what is negative 2? Well, the only two numbers that multiply to 2 are going to be 2 and 1. But now I want it to equal to a negative x, so that means that the 2 has to be negative and the 1 will be positive. Okay? Now, can anything factor out here? No, meaning that I am going to have a vertical asymptote. I'm going to have two vertical asymptotes because I have two factors in my denominator that were not canceled out in the numerator with anything. So for my vertical asymptote, I'm going to have x minus 2 equal to 0, x plus 1 equal to 0. Add the 2, x equals to 2. Then get the plus 1 equal to 0. Subtract the 1. X is going to equal to negative 1. So my vertical asymptotes are going to be at x equals to 2 and x equals to negative 1. So here I'm going to have two vertical asymptotes. Okay? Now for the horizontal asymptote, I have the highest degree here, which is 1, and then the highest degree here is a 2. Okay? So that means that for the horizontal asymptote, I'm going to have 1 over 2, right? Which is 1 is less than 2, which therefore means that I am going to have an asymptote at y equals to 0. And if you guys don't remember those rules, just go back to your notes and it's going to be right there. So make sure to remember those rules. So here it's going to be at y equals to 0. Okay? Now we move on to find our zeros, which are our x-intercepts. Okay? And that means that we get our numerator, and we set it equal to 0. So that means x literally equal to 0. There's nothing else I can do. So my zeros here are just going to be at 0, 0. Okay, guys? That's literally it. Remember, you get x-intercepts when you make y equal to 0. But it's just x, so it's x equals to 0, so it's 0, 0. Now for the y-intercept, we make x equal to 0. So we're going to go ahead and get the original function. So we're going to get y equals to 0 over 0 squared minus 0 minus 2. 0 squared minus 0 is just 0, so you're going to get 0 minus 2. What's 0 minus 2? Well, that's a negative 2. But 0 divided by negative 2 is just going to be a 0. So where's my y-intercept? At 0, 0. Okay? Now here, are we going to have any removable discontinuities? No, because was I able to cancel anything out and get rid of it? No, right? So here, my removable discontinuities are none. Okay? And these are basically going to be continuities. These are basically going to be talking about the wholes, right? So in this situation, do we have any? No. Okay? Now, do I have non-removable discontinuities? Yes, I do, right? Because if you look at this, do I have something in my denominator? Yes, I do. It's x minus 2, x plus 1. But we already found what those were, right? Because the non-removable discontinuities are going to be your vertical asymptotes right here. So these right here are going to be your non-removable discontinuities. So we already found those, okay? So now the only thing would have been to worry about the wholes. But in this situation, we don't have any because we did not get rid of any common factors, okay? So all that's left is to find the domain, okay? Well, what's my domain going to be? My domain is going to be all x values such that x cannot equal to 2 and cannot equal to negative 1. Okay, and why is that? That is because we have vertical asymptotes, right? And if you don't feel comfortable doing the domain and the range until after you've graphed it, then that's totally fine, okay? And for the range in this situation is going to be y values such that it is all real numbers, okay? And you'll see why in a little bit. So now let's go ahead and do a sign chart. Okay, and I'm going to use x over x minus 2x plus 1. Okay, and we have to use the zeros. So what are my zeros? 0, 0. Okay, and we have to use the vertical asymptotes, which are 2 and -1. So I'm going to go ahead and I'm going to use -2 here. So I'll have -2 over -2 minus 2, -2 plus 1. -2 is going to be negative. -2 minus 2 is going to be negative. -2 plus 1 is going to be negative. So a negative times a negative is going to be a positive. So I'm going to have a negative divided by a positive, which is just going to be negative. Okay? Now for between -1 and 0, I'll use -0.5. So I'll have a -0.5 over -0.5 minus 2, -0.5 plus 1. So that'll be a negative. A negative minus a negative is a negative. -0.5 plus 1 is going to be a positive. Okay? So now a negative times a positive is going to be a negative. So now a negative divided by a negative is going to give me a positive. Okay? And now anything between 0 and 2, so I'll choose 1. So I'll have 1 over 1 minus 2, and then 1 plus 1. Okay? So that's a positive. 1 minus 2 is a negative, and then 1 plus 1 is going to be a positive. So once again, a negative times a positive is a negative. So a positive divided by a negative is going to be a negative. Okay? And now anything greater than 2, I'll choose 3. So I'm going to have 3 over 3 minus 2, 3 plus 1. That's a positive. Positive times a positive. So that's just going to be a positive. Okay? So let's go ahead and graph this. So I'm going to go ahead and I'm going to start off with my vertical asymptotes, which is going to be at x equals to 2. 1, 2. Let me use a different color. And then I'm going to have that at -1 as well. Okay, and now my horizontal asymptote, which is going to be at y equals to 0, so I use another color for that one. So that's my horizontal asymptote at y equals to 0. And my x equals to 2, x equals to 2, and x equals to -1. Okay? And now my 0, which is going to be at 0, 0, so I'm going to have that point right there. My y-intercept, which is also at 0, 0. Okay? And so now we start this. So here I am at -1, right? And this line right here is my -1. Okay? Well, what happens here is that I want the values to be negative, right? So if anything from -1 right here, if this is split between the positive and the negative side, and I'm looking at this above the y-axis and below the y-axis, not the fact that it's on the left side of the x-axis, I want to create a graph here that is going to be on the negative side. Now, do notice that I have two boundaries, okay? I have these two boundaries right here, okay? So what I want to do is I want to create a function that follows these two boundaries, leaving me to create a function that goes like this. Okay, and I have to follow the vertical and the horizontal asymptote. I also know that it's going to be negative, so that's why I drew it on the bottom half and not the top half. Okay, now the next one here, I start at my value, my 0, which is that one right there, and it says that between -1 and 0, I have to be positive. So between -1, which is right here, between -1 and 0, which is my point right there, I have to be positive. So from this point, I'm going to go upwards, but I'm going to follow the asymptote, right? So it goes up like this, following the asymptote. Okay, and then from 0 to 2, I ended up being negative from 0 to 2. This is my 0 point, and this is my value of 2. So that means that from here, I have to curve this in a way that goes downwards, following the asymptote. Okay, and then from 2 to 3, or from 2 to the right side, it says that my values have to be positive. So once again, here I have to follow the asymptotes here, and I have to keep it positive, meaning it's going to be on the top half and not the bottom half. And once again, we have to make it follow the boundaries of the asymptotes. So your function would look like that. And if you guys don't believe me, you guys can just go ahead and graph the function in your calculator, and you will see that this is what the function looks like. But the whole point of the sign chart is to help guide you in graphing these functions right here. Okay? If you have any questions, just let me know. Have a good one.